Okay, good morning everyone, and welcome to about the MSc Renewable Energy course at the University of Hull. The number of people joining has steadied off now, so I think it's a good time to start. My name's Simon. I'll be hosting this webinar this morning. The Renewable Energy course is run out of the Energy and Environment Institute within the university. So to kick us off this morning, I'd like to introduce Professor Dan Parsons, the director of that institute, to give us an introduction. Over to you, Dan.
Thanks, Simon, and welcome everybody. Thanks for coming along today to listen to the information that we have around our MSc in renewable energy. It's just for me to welcome you all here to the webinar today, to listen to my colleagues detail the program and what it contains and where it can take you into the future. I guess the rationale for us putting on a program like this in Hull is that Hull is now the global centre for offshore wind developments, worldwide, recognised. And the work that we've been doing at the university around the renewable sector has grown exponentially over the past few years. Leading to, for example, some of the papers to the Council of Europe that we've been working with Lord Prescott on, through to establishing collaborative clusters and innovation centres around the low carbon transition the journey that societies globally need to go on. So with that and that context and the growth of this sector into the future that we're all very excited about at the university, I'll hand back to Simon, the rest of the team, and I'll look forward to seeing you at the end, and any questions that you may have that could be directed to myself. So Simon, over to you.
Thanks, Dan. So some introductions into the other people who you're going to be seeing today. I'm Simon, as I said. I lead the Renewable Energy course, and I teach a significant part of it. My own research background is tidal energy. Next up, through this slightly dubious selfie, we see Stuart. He's the Deputy Director of the Energy and Environment Institute, but perhaps more importantly, he's the other main lecturer on this course. So between us, we probably cover a little bit under half of the talk material, and then there are lots of other people in their specialist areas. So if you choose to come and study with us, you'll be seeing quite a lot of both of our faces. I can leave it up to you to decide if that's a good thing. We also have three panel members who are with us today to help answer questions. They are Agatha. She's a researcher with EEI. She works on the effects of waves on offshore wind turbines and predicting them using computer modelling. Kia is an environmental engineer, and she's working at present on improving the forecasting of wave conditions using satellite images and machine learning to help companies be able to predict when it's going to be safe to do maintenance on offshore wind turbines. Finally, Samson is a final year PhD student with the Centre for Sustainable Energy Technology within the university. He works on innovative solar systems that can use more of both the light and the heat that they absorb. And before starting his PhD, Samson did a master's in electrical and electronic engineering here at Hull. So the reason for introducing all those people, here's a quick outline on the screen of what I'm going to talk about today. The reason for introducing them is that we'd like you to ask us questions. And you can ask questions using the interface on the right-hand side of your screen. If you can't see it, you might have to tap the little orange arrow to make it appear. And you can ask questions throughout today's session at any time. Stuart is going to be keeping an eye on those questions as they come in. If they are very specific to your circumstances, he might answer you directly in text form. But if they're more general, he'll probably save them up until the end when we can put them to the most appropriate member of our panel. And those questions, of course, they can be about the course, and those questions are very welcome. They can also be more generally about Hull, what it's like to live or work here, and about the surrounding region. Or they can be simply about energy, renewable energy preferably. We have quite a wide range of expertise on the panel, so hopefully we can get some interesting questions for everybody, and we'll answer as many as we can. But first off, let's start by hearing from a local employer and some of our postdocs and PhDs. I've got a short film for you. Now, because of the software we're using, that film will appear in its own window, and it might show up behind something else on your screen. So if you find that you can hear it, but you can't see it, just have a rummage around and see if it's behind something else.
The MSc at the University of Hull, I think, would be a really good step on your career pathway. Hull is in the centre of the Humber Estuary, and the Humber Estuary is an absolute epicentre for all things renewables. It is known as the energy estuary. This means for you studying at the University of Hull, you'll also get the opportunity to really get out and see what this looks like on the ground.
We're in an energy revolution, and the University of Hull is leading the way in the search for alternative, greener approaches of producing fuels and energy. The Humber region is a perfect platform for such work, as we're supported by many local industry partners, and we're all striving to fight climatological disaster on a global scale.
There is no better place to research offshore wind than Hull. It's right in the center of offshore wind sector, with numerous wind farms located just off the coast and very strong connections with sector-leading industry, such as manufacturers Siemens Gamesa Renewable Energy, who have their blade factory right here in Hull, or Ørsted, who operate the wind turbines from their facility just across the estuary.
The aspect of my research that I really enjoy is using academic knowledge to solve real-life problems and helping towards a sustainable future.
Being within the Energy and Environment Institute has also been really great, being constantly surrounded by so many postgraduate researchers and lecturers with such a broad knowledge base and a wide variety of fields. I look forward to completing my PhD and to having a career within the research industry and helping towards a more sustainable future.
We have been able to work with Siemens Gamesa graduate apprentices. They were in some of our lectures in our first semester, so working with them means that they were able to give us the practical application and we could kind of give a little bit more of the theory.
The demand for renewable power generation in the future will only continue to grow, and for you that means that the career prospects in this industry are always going to be in demand. All of these different aspects come together to be able to make this happen, and you could be one of those people.
Welcome back. So the first question I want to look at is why you might want to study renewable energy. And you probably have some ideas on this already if you're here, but here's a one idea. This is a chart showing the UK's greenhouse gas emissions last year by sector. And we can see on the left about a third of it is from transport, about a quarter is from producing electricity, 20% there on businesses and public buildings, that is mostly heating and cooling, and then 18% in homes, that's almost entirely heating, or heat at least, it includes hot water. So that's, if we include the energy used for transport, that adds up to about 95% of our greenhouse gas emissions coming from transport. The remaining bits down the bottom you can see are industrial processes and agriculture. But it's 90%, sorry, I said transport, 95% of our greenhouse gas emissions coming from energy. That's a slightly limited way of looking at it because it's territorially limited. It's only what gets emitted within the UK. So if we outsource manufacturing of a product to another country, then we also outsource those greenhouse gas emissions. So some people argue this is a slightly unfair way of looking at it. And certainly if we look at the worldwide figure, it's somewhere between 60 and 80% of worldwide greenhouse gas emissions that come from energy. But the point I want to make here is that our climate problem is largely an energy problem, in that energy is the biggest emitter of greenhouse gases. So that's one reason why one might want to study renewables. A second reason is a bit more pragmatic. Here's a chart from government figures showing the growth of renewable electricity in the UK from 2001 up until a few years ago. And just at first glance, you can see the scale of that growth and how it's accelerating. Hydro's been quite constant over time because most of that was built in the mid 20th century, but you can see how onshore wind exploded, and then how offshore wind exploded, and then how solar exploded. Bioenergy is the other component there, but it's a bit more complicated, so I won't go into it here. But the point is that growth is set to continue, and that means that the demand for people is going to keep growing. At present, the renewable energy industry in the UK employs about 30,000 people. That's only going to increase. The offshore wind sector has said that they alone need another 17,000 in the next 10 years. And there's a recent National Grid report that you might have seen in the headlines that was looking at what Britain would need to do to reach net zero by 2050. And they concluded that to reach that target, we needed to have over 100,000 new people working in green energy by 2030. So that's massive. Now, of course, we don't know whether net zero by 2050 is going to happen, but if we even make an attempt towards it, a lot of skilled people are going to be needed, and people who understand energy are going to be in demand. So that's another reason why one might want to study renewables. And what jobs are these? It's really easy when we think about renewable jobs to think about engineers and think about wind turbine technicians, for example. But in fact, this is a set of screenshots from a project called Faces of Wind Energy. It's probably still making its way over the internet to some of you. This is a project aimed at capturing a lot of the different roles that exist within wind, and you probably can't see the small text, but just clicking through a few of these, we've got a health and safety coordinator, we've got a design and quality engineer, we've got some technicians, quality engineer, business coordinator, design team leader, a master mariner, project manager here, but not in directly an energy company. This is a project manager for a trucking company that's moving wind turbine blades around. Project managers, civil engineers, training coordinator, procurement, maintenance. That's just the people working directly in the wind industry. There's also a whole host of companies supporting them with goods and with services. So you have environmental consultants, resource analysts, legal and commercial people, marketing, sales, comms, finance, survey, geotechnics, logistics, etc. Pretty much any role that you can think of as existing within any industry is going to exist within renewables. So this is something I often try and get across to people, that it's not just about engineers doing their thing, it's really about all of us. And we're not about to make you into a specialist in any one of those things. You're not about to drop into most of those jobs without specialist training, and that's fine because those companies recognize that and they recruit graduates and train them. What we aim to do is to give you the broad background to be more employable. We want to make sure that engineers understand what's going on with the ecology side of things, that ecologists understand what the engineers are talking about. We want to make sure that the finance specialist understands the constraints that all the other people are working under. And we think that the companies out there really value people having this breadth of knowledge of all aspects of the operation before they get trained into a specific role. So having said that, I'm not going to go into the details of that, but if that's of interest, then please ask a question about it. And we operate 3 semesters at Hull, which we call trimesters for I don't know what reason. 3 semesters of 4 months each. So the first 2 semesters, which is roughly from September to the end of May, you study 6 taught modules. And then in the 3rd semester over the summer, you do a dissertation. And the dissertation is what really makes a master's course different and unique compared to what you've done before, because it's genuine new research that no one's done before on a topic of your interest, supported by a supervisor with expertise in that area. And some of those supervisors are the people we got on the panel today. It's student-led, so we'll offer support and guidance, but it's up to you to drive the dissertation. And often it's done with industry or with local authorities and so forth if they have a problem that you can solve. But equally often it's done purely within the university, and it works fine either way. There's no exams on this course. It's all about the coursework, which will be a delight for some people, I'm sure. The 3 modules that you see highlighted in blue here are taught jointly with the master's course in environmental change management and monitoring. And I'm really happy about this because environment and energy are really tightly linked concepts. All energy systems have environmental impacts. There's no free lunch here. But the whole reason we're doing this is that we think the environmental impacts of renewable energy are preferable to the environmental impacts of fossil fuels. But they do exist, those impacts of renewables, so it's really important that they're understood and that we can predict them when we are developing renewable energy systems. So it's really helpful, and our students find it really helpful for the people on both courses to be able to work together and to get the perspective from the other side of the equation. I've actually got a quote here to illustrate this from one of last year's students. Excuse me. Amina came from a chemical engineering undergraduate, but she has said here she was able to work with biologists, electrical engineers, environmental scientists, and so forth, and was able to really get different perspectives working in a more diverse team than she had during her undergrad. And I should mention here, we say on the literature that we welcome any STEM subject, and that's kind of the default situation. We definitely do. But we'd also love to talk to people from non-STEM subjects. If you haven't done much science, engineering, or maths recently, you might have a little bit of extra work to do. But in general, if you are dedicated and really keen on understanding energy, then we're sure you have something to contribute, and we'd like to talk to you about it. What I'm going to do now is go through each of those modules in a little bit of detail. This will take a few minutes, but hopefully give you quite a good overview of the course. So we start off with principles of renewable energy in semester 1. And this has a bit of background and a bit of context and introduction, so you understand the UK and the global energy situation. But mostly it consists of the basics of a lot of renewable energy sources, so wind, wave, hydro, etc. You get an introduction to how they work, to the main design decisions that people go through when they're developing them, and to look at how high-level resource assessment is done for each one. So how one might look at an area and estimate how much energy is available from that location. At the same time, we'll be working on the horribly named Research Issues in Environmental Management and Renewable Energy. I'm pleased to say the name is the worst thing about it. This module is split roughly into 2 parts, and one part is based around student-led research around the links between environmental management and energy. So groups of students choose from a list of topics, pick a topic, go away, research it, and report back to the class. And that means between all the groups, we can cover a lot of ground while also allowing most people to work on something that interests them. And also it means that you gain some experience with doing research in the scientific literature and with doing presentations. The other half of this module is in looking at your dissertation project. Nothing's set in stone at this point in the year, but it's when you'll provisionally decide on a topic and get allocated a supervisor and work with them to put together a project plan for the summer. The third module during this first semester is environmental and energy data literacy. And this is simply about how to find data, how to understand it, analyze it, and present it using both quantitative and qualitative techniques. So these are methods that will be valuable to you throughout the rest of the year and hopefully through your careers. And it's taught jointly with the ecology students, but we normally try to make sure that there are plenty of energy-based case studies and examples to keep things in a context that the energy students find familiar and useful. Then we come to roughly the Christmas break, and then from January we move on to semester 2. And the module called Low Carbon Energy Solutions is, in some ways, it's a follow-on from Principles of Renewable Energy, but it's looking at all the other factors that affect renewable energy development that are not to do with the technology or the resource itself. So, for example, different maintenance strategies you might adopt, the implications of grid connections and grid capacity limitations, finance and different forms of government support that might be available, and also looking at some things like energy storage and some demand side things like building design and energy efficiency. At the same time as that, my slide didn't advance. At the same time as that, we're doing applied renewable energy. This is quite an unusual module. It can be summarized as get as much contact with the real world as possible. So it's all about introducing you to the people who are actually doing this work rather than purely the people in universities who are talking about it and researching it. So it consists of site visits, guest lectures, and also some practicals. Some site visits might also happen earlier in the year. Last year, we visited a hydroelectric scheme, a solar farm, a wind farm, and a large biomass power station. Site visits next year are obviously going to depend on the pandemic situation, but this module is early 2021, so hopefully we can get out and about a bit of it by then. I'll talk a little bit more about COVID later on. Guest speaker wise, again, it's trying to bring in as many people as we can who are doing this in the real world, and that's people from industry, but it's also from regulators, from community energy schemes, and as well we bring in some researchers who are working on energy topics within the university to give you a glimpse in some more advanced topics that we might not otherwise cover in the taught material. The practicals in this module, they let you play with some miniature wind and solar systems to help understand some of the factors that affect the energy resource there. And we also usually squeeze in a day's tutorial on some of the industry standard software that is used for wind farm design. And that means you can get familiar with that and you can put that on your CV that you're familiar with it. And some students even use it in their dissertations. It's there and available if you need it. The final out of the 6 taught modules is environmental impact assessment and spatial data. This is a new module. It's still being designed at present. The idea is that it's centered around the methods and mechanisms of environmental impact assessments, because so very much depends on those. But it brings in remote sensing by using satellite data and spatial data to inform the EIAs. And it has a strong use of GIS tools, of geographic information systems, which again means that you get familiar with those industry standard GIS tools and you can put them on your CV, which is hopefully really helpful for people. And jointly with the other masters, but we make a point of trying to make sure there are energy-based examples, at least for the renewable energy students. I've got to address the question about COVID. My answer to it is we don't know very much yet, and that's simply because it's impossible for us to know what the national situation is going to be like in September and even in January or later in the year. So no definite decision has been made on exactly what we're doing. What I can say is that we've been planning for 3 different contingencies. We've been planning for being fully back on campus, which is unlikely to happen, we think, this September, but could very well happen later during the year. We've been planning for being partially on campus for the aspects of the course that will benefit the most and which can be done safely. So, for example, we might be able to do practicals on campus, but not most of the lecturing. And we're also planning, if necessary, for being entirely online, which might still be the case in September. Obviously, we don't know yet. So I can't tell you exactly what's going to happen. I can tell you we're putting quite a lot of effort and thought into making sure that whatever happens, we can definitely give you something worthwhile. Feel free to ask more questions about that, and I'll try, and we'll all try to answer more, but we probably don't know very much more at this point. So we've talked about why you might want to study renewables. We've talked about what you cover in the course here. I've done a little bit of searching through LinkedIn recently to see where some of our alumni have ended up. I'm not going to read out this slide, but just have a skim through for yourself. I think the point to draw out of it is, again, the range of roles we're looking at here. There are 1 or 2 engineers in there, but there is a whole host of other things as well. And then the last remaining thing to talk about, we talked about why to study renewables. We talked about why you might like to do this course by looking at the content of it, but also why is this a good place to do it? There's a few different reasons for that, But the Humber estuary where we're situated is sometimes referred to as the energy estuary because 24% of all the UK's energy passes through this region. And that's not all renewable at present. That includes North Sea gas pipelines, oil refineries, and so forth. But it also includes the world's biggest offshore wind farm. If you look at the map on the right, this is showing all of the offshore wind in the southern North Sea that is either built, being built, or planned to be built. It's a few days out of date from when I took the screenshot. If you look down at the bottom near London and go east from London, you can see a roughly triangular dark blue wind farm there. That's the London Array. When that was built in 2012, I was actually on one of the ships doing it. That was the largest wind farm in the world. And as you can see, we've come a long way since then. If you look at where Hull is near the top and go east from there out into the North Sea, you can see a dark blue shape inside a light blue shape inside a white shape. And that's the Hornsey development. That is currently the largest wind farm in the world. That medium blue section is 30 miles across, which is the part that's currently under construction. So that gives you an idea of the sheer scale that we're looking at here. And there are plans for this to carry on increasing at faster and faster rates. And a lot of this build out, Hornsey, but also some of the others, a lot of the build out is happening from Hull and from the Humber. So Siemens Gamesa, who are a major turbine manufacturer, they have their blade factory in Hull. We actually teach some of their apprentice engineers at the university. So they make their blades and they assemble turbines and they put them together and load them onto the vessels that are going out to install them. Ørsted is a large Danish company that owns and operates a lot of these wind farms. They have one of their main maintenance bases in Grimsby, just across the estuary. So that's where people board the boats that are going out and doing all the servicing. We've got a few major companies like that, and of course supporting them are their supply chains. So lots and lots of smaller companies doing work around the region. And some of these people will come and speak to us in guest lectures, but probably more importantly, they're all potential employers who are local and who are familiar with the course at Hull. And as you see in the previous slide, all of whom have had at least some of our students before. Aura Innovation, which I've got the logo for there, is a university initiative to connect the university with these companies and to develop innovation around offshore wind. And offshore wind is a focus of this because of what's going on around Hull, but there's a lot of expertise also within the university on biofuels, on energy from waste, on hydrogen, tidal energy, and so forth. And in fact, the university has a commitment to reach net zero on its own campus by 2027, which I believe is the earliest date of any UK university. And as part of that, at present, we're looking into building our own wind farm, our own solar farm on university land. And so there's a hope that as that project gets underway, we might be able to feed some of that back into the teaching as well. I've got a bit more information about Hull and about the Humber region for you in another short film. So once again, this might pop up behind something else. You might need to go hunting for it, but please enjoy.
I'm Daniel Parsons. I'm a professor up at the university, and I'm the director of the Energy and Environment Institute at the university, which seeks to bring together multiple disciplines into one collaborative arena where we can really seek solutions that we in Hull and the Humber really can drive and lead on internationally as we move forward into what's been called a zero carbon world. So in the Humber estuary, along the east coastal margin, big changes are happening because of storminess, increase in storminess, and also sea level rise. We need to address this. We need to begin to tackle some of these solutions around pollutants of carbon into the atmosphere, but we also need to think about the way in which we mitigate and adapt the effects that are already going to happen in terms of the climate of Earth. The Living with Water partnership, which we're very proud at the university to now be contributing and working towards. That is all about adaptation, mitigation, living with water. We will flood again, but how do we become more resilient? How do we ensure that our recovery is really rapid? And how do we ensure that we're prepared as a society for this into the future? The Humber is really much at the forefront, on the front line of climate change in a whole host of ways. And when we look at the capacity of wind energy globally, it's exponential. The speed of growth is unbelievable. And that's because the costs have been driven down so quickly. Wind could supply enough energy to sustain the whole of humanity 40 times over. The university and all of the partnerships through Greenport Growth and now the Aura collaborative cluster really coming together, shaping the future of this massive industry, the offshore wind sector. And we're embedded as a region within the UK government's sector deal for offshore wind. We're leading nationally and internationally on this. People are looking at us, at what we're doing in terms of capitalising on the opportunity of offshore wind. The renewable revolution that's happening right here can help address all of these challenges associated with the climate crisis.
Welcome back once again. So we're getting towards the end of our presentation this morning. One thing still to mention is scholarships. Based on, I think, money donated by alumni, we have a number of scholarships of £5,000 available to contribute towards your studies on this master's. There are some really specific eligibility requirements. Please don't be put off by me saying that, because while they are specific, they are quite inclusive. So do go and have a look. I'll give you the website on the next slide. But please be aware the deadline to apply for those scholarships is the end of July, which is much earlier than the deadline to apply for the course as a whole. So if you think you might be going for those, then do get a move on. And there are also various other bursaries and scholarships available at the university. In particular, if you are a Hull alumnus, if you did your undergrad here, then you automatically get a discount on master's courses as well. Details of that on the university website. With that, summing up, I'm not going to read that out, you can read it yourself, but broadly we are aiming at employability. We're aiming at giving you a broad overview of all aspects of renewables. Please go to the website, please have a look. There's a lot more detail there, and also the route to apply there. If you have other questions you think of after today, if you go to the website, you can also find our email addresses to get in touch with us, and we're happy to answer your questions either by email or on the phone. But if you have questions now, we can of course ask them of our panel. And I believe Stuart's been looking at quite a lot of questions coming in throughout the talk, which is fantastic. please, you're welcome to ask more questions now if you want to, right up until we hit that finish button. But for now, I will ask the panelists and Stuart, please to turn your cameras on, and I will pass over to Stuart to lead us through the questions. Thank you very much.
Okay, thank you, Simon. That was a great presentation. I think covered a lot of detail in terms of what the course is about. I'll just give everyone a brief opportunity to, the other members of the panel, a brief opportunity to introduce themselves, and then we'll go through some of the questions that people have been asking. So I'm Stuart McClelland, I'm the Deputy Director of the Energy Environment Institute. And Agota?
Hi everyone, my name is Agata. I'm an engineer by background, but I'm a researcher here at the Energy and Environment Institute now. I'm researching wave loads on monopile supported offshore wind turbines.
And Evdokia?
Hello all, I'm a postdoctoral research associate at the Energy and Environment Institute. I'm working in maintenance for offshore wind turbines. I'm using satellite images and machine learning so I can increase the resolution of forecasting of waves.
And Samson?
Hi everyone, my name is Samson. I'm a final year PhD candidate at the Center for Sustainable Energy Technology. My research is actually on innovative thermoelectric and photovoltaic thermoelectric systems for power generation. Thank you.
Okay, thanks. So I'll read out some of the questions that we've been getting, and hopefully myself and the rest of the members of the panel will be able to give you some answers to these. So one question we've got here is roughly how many students are usually on this course each year? Well, I'll sort of start off with an answer to that. We sort of expect about 25 students, but it does depend on the number of applications that we get each year, how many people will be on the course, but around about 25 would be what we would expect. Maybe this is one, Simon, you could pick up on it. Somebody asking about whether or not there's support during the data literacy module that's in the first semester. Somebody thinking it might appear fairly daunting and wondering sort of what support we'll offer to help people.
Yes, absolutely. This is not a case of dumping you in the deep end. It's the whole point of the module is to develop your skills with data, recognizing that we have people coming to this course from a really broad range of backgrounds. For most people, there'll probably be one aspect of this course somewhere there's going to be revision for them. So for some people, they'll be quite familiar with data and statistics already, but other people it'll be new, and that's fine. If you were looking at the picture that I put on that slide, please don't read too much into that. It was just a freely available picture I grabbed off the web to illustrate that particular module.
Okay, there's a question here about whether the program is focused on wind energy. Just to say, no, that's not the case. It's titled Renewable Energy, although clearly because of the amount of offshore wind associated with the Humber region, you know, we obviously cover that in great depth and detail, but it covers all forms of renewable energy, not just wind energy. I was wondering, maybe Simon, you could pick up on this. There's obviously, we've mentioned that there's strong links with some of the offshore wind companies, but what about the links that we have with other renewable energy companies? Maybe you'd like to mention a couple of those.
Yes, obviously the strongest, well, I wouldn't say the strongest, the largest scale thing that's going on are offshore wind, which is why we tend to talk about that a lot. But we've got at present a research group working with a nearby energy from waste company that is looking to improve their processes and improve the efficiency of their plant. Actually, one of our students this year is doing his dissertation with an anaerobic digestion firm in North Lincolnshire. And there are a number of other companies in solar farm that we visit, well, this year we visited, and we hope to rearrange that next year. So there certainly are other links and other opportunities there.
Okay, a question maybe Samson would like to answer. What do you think are the academic career paths that might be available after the MSc? I mean, clearly you've gone on to do a PhD. Maybe you could talk a little bit about how careers can develop.
Samson, I think you might be muted. We can't hear you.
Sorry, can you hear me now?
Yeah.
Sorry about that. I did my master's in 2017, and one of the modules I actually took was on renewable energy for buildings. And the interesting thing about the module was it was actually taken by my current PhD supervisor. And what I enjoyed the most about the module was he taught the module using actual funded projects he was working on at that time. So I had a real life experience, like it wasn't just theories. It was actually practical things, practical research he was working on. And that was one of the reasons, or the main reason I decided to pursue a PhD. And I'm really glad I did that. Thank you.
Okay, we've got another couple of questions about contact hours. I think probably the key thing to say there, it does vary because we do field trips and practical exercises, and what's running in each week does change, although we do try to timetable activities on the same day so that that's as convenient as possible for people. But I would say a good approximation is about 20 hours, but it does fluctuate depending on which modules you're doing, where you are in the module, what coursework you're working on, etc. I don't know if there's anything else to add to that, Simon, with that?
No, I think you've probably got a better handle on that than I have right now.
Okay. And somebody asking whether or not biofuels are covered at all. I think maybe Simon's answer about one of the students working on it for the dissertation project, so it looks at that. And specifically in the first semester, we have a set of lectures looking at biofuels, because there's a big sort of research effort actually going on in the University of Hull looking at biofuels. So we pick up on that and make use of that.
To the person inquiring about biofuels, if you want to read a bit more, you could look up the THYME project, THYME. That's the project at the university that I think Stuart was referring to.
There's a question about whether or not employers employ just those who've finished a master's, or would they be looking for a PhD? I mean, I think that's, you know, that there's scope to take both trajectories in terms of looking for a career in renewable energies. Particularly if you're looking for a more sort of academic line, then you might go down a PhD if you're looking at sort of academic research. But many, I think, as Simon put up on the slide earlier, many of the graduates from the MSc program go straight into employment in the renewable sector. So both opportunities are there. Maybe Agota, you'd like to talk about sort of the research side of things and how you got into your field of research?
Sure. Well, it all started with the master's for me as well. I did my master's project on urban wind and urban wind harvesting on the campus of my university. And I just liked it, like the research project, so much that I didn't return to the engineering company I worked for during the summers and chose the more academic pathway. I went on to do my PhD, chose offshore wind for that. And now I'm doing research here at the University of Hull, which I'm enjoying a lot. And yeah, it's really exciting to see how your findings can be implemented in the real life. You're sort of digging through the limits of the human knowledge, and then that can be commercialized and implemented in the real life.
Great. Great. There's a couple of questions here about scholarships as well. So just to remind everybody that if you look on the web pages for the MSc program, then you'll find links to the scholarships which are available. So we have a number of scholarships available for £5,000, which you can apply for up to the end of July. Somebody was asking when people would find out about that. It'll be towards the end of August, obviously, once we've looked at all the applications, that we'd be able to notify you about that. We do it as soon as it was possible. But there are also scholarships available for graduates of the University of Hull, where there's a £1,000 reduction in fees if you're a Hull graduate. So again, if you look at the web page, then you'll be able to find out more information about the support that we can provide. It's also useful to remind everybody that there's a loan system available from the government. So if you want to undertake MSc study, then you can get a loan for up to £11,000 towards the fees. Again, I'd suggest you look at sort of the government's websites on those things If you email the EEI, we'd be able to pass on any information that you needed about that. I'm just looking, there's quite a long list of questions. It's just trying to gather some of these together. So that's, we've looked at scholarships there. There was a question, a sort of interesting question here about whether or not the program focuses solely on centralized grid-based systems, so sort of the bigger infrastructure for providing renewable energy like the large offshore wind farms, or whether we look at localized building level applications. Well, undoubtedly it's both that we look at. Whilst, you know, there's a huge amount going on in offshore wind, but in the first semester, one of the things we do is go and visit a local community initiative, which is hydropower based up in the North York Moors. And also in the first semester in the Principles of Renewable Energy, we look at building based sort of design. So how a whole building can be designed in order to reduce energy consumption, which is all a part of making best use of renewable energy. Sorry, Simon, you were going to.
Perhaps I could chip in a little bit there as well. I think some of what you said about being a principal, we might move into low carbon energy solutions this year. But yeah, so Stuart's absolutely right that when we're looking at the different renewable energy technologies, most of them are applicable at a wide variety of scales, from a household to a community to a major utility grid system. And we do look at all those scales when we're looking at the technologies. I think it would also be fair to say, and we do cover some of the demand side aspects about building efficiency and that kind of thing. But I think it would be fair to say that we are focused on the generation side of things, but not necessarily only large scale grid generation.
So one other question I could answer quickly about whether or not the skills gained are suitable for overseas employers. Yes, I think undoubtedly that's true, because essentially the problems faced by the renewable energy sector are the same the world over. So the things that we're looking at apply throughout the globe, really. Somebody asking about whether or not part-time students are integrated with full-time, and yes, that is the case. So we teach everybody together. The difference being, if you study part-time, you'll just do it, you know, over a 2-year period rather than a 1-year course. And there's a question about whether or not there's an impact. The impact on wildlife is considered. Somebody with some expertise outside. Yes, we entirely sort of want to embrace that side of things. It's not just about renewable energy itself, but it's actually how we make best use of renewable energy and how we develop renewable energy. And in order to do that, we have to think of the environmental impacts beyond just what's happening locally to the system itself. So yeah, looking at the impacts on wildlife, it is an aspect of things, and that could be something that could be picked up in somebody's dissertation project, for example. And again, I think as Simon alluded to, that's a really good reason why this course is taught in combination with and in conjunction with the Masters in Environmental Management. So we're considering sort of all sides. It's not a sort of technological approach solely. We're sort of looking at how the technology works, but also understanding practically how do we bring that into the real world. I'm looking to see if there's any other questions that we've not picked up on here. There's quite a long list.
I will add that there is obviously a long list. If we don't manage to pick up on, if there's something we think we picked up on but actually we haven't, and which is still a burning question for you by the time we finish, you're of course very welcome to drop us an email, and we'll happily answer it for you personally.
Yeah. There's a question here about how long the dissertation is. The dissertation's a 60 credit module, so it's something that you write up over the summer, and correct me if I'm wrong, it's 18,000 words, I think is the word limit, or off the top of my head.
I'd have to look that up.
Yeah, I think it's about that. But you do it over the summer period, and yeah, it's worth 60 credits, so it's about a third effectively of the MSc. Yeah, I think we've picked up everything that came in at the end. I'll just see whether there were some other questions that people asked during the presentation, which I tried to answer. Yeah, I think we've picked up. But there was one question about the level of maths required, just to sort of generally say and encourage people that the way the course has been designed is to be as accessible to a broad. We're not teaching just to engineers. We're not teaching just to scientists. What we've done is develop a course which can take in a broad range of different disciplines, because renewable energy needs to be looked at from a number of different perspectives. That there's not one single answer to solve the problems that we have. So really, we encourage applicants from all subject areas. We do request or suggest on the entry requirements that you have GCSE maths or the equivalent of that. So again, we'd look at all applications and consider them to look at your background and what your experience is. But we try and teach it from as broad a perspective as possible to be inclusive to sort of people's experiences from different disciplines. Okay, I think it's fair to say we probably answered all of the questions there. Is there anything else that you can see, Simon, that we need to pick up on? I think maybe just the last thing I'll say is that there were, again, a couple of questions sort of during the talk about where the focus on what energy resources were. Again, we picked up a bit on this in the questions, but just to say, wind energy is important, but we cover all forms of renewable energy. Some in more detail than others because they're more important and more significant, but that it's really a very broad program.
Yeah, I would add to that we have people within the university who are working on solar, like Samson is. I work on tidal myself. Of course, we have plenty of people working on wind. There's a big group, as we've said, working on biofuels. And all of that does, to some extent, come into the course. There was something else I picked up here that I wanted to briefly mention, and I've lost it again. Too many questions, which is a good thing. Oh yeah, someone was asking about how applicable the teaching would be for internationally for overseas employers. What I would say is yes, absolutely applicable. We tend to use the UK as an example a lot of the time because it's the place that perhaps the most people on the course are the most familiar with. But I try to make a point of making sure that we cover what happens in the rest of the world. Most of the techniques we're using in the UK will also be applicable in other places as well. So I would not have any concerns on that front.
Perhaps also one just last thing, just to maybe give a general answer to people about mature students, that there have been a lot of mature students that have been on the course before, and we would encourage applications from mature students, particularly if you're thinking of changing career. It's an opportunity to do that. So again, any specific questions, get in touch with us at the EI or Simon or myself specifically, and we'd be happy to help with that and discuss the opportunities. Okay.
So with that said, thank you, Stuart, and thank you to the panel, and thank you to everyone who's asked a lot of excellent and interesting questions. So I'll wrap up there. Once again, our web address is there. Please go and have a look. Please bring in your applications. Please send us any further queries. We're really happy to correspond by email or to have a chat on the phone or Zoom or whatever. And I look forward to seeing some of you in September. Thank you very much.
Yes, thank you for joining us.